Okay, guys, let's continue now with the second part of a review in Chapter 9 here and look at problem number 24. G of x equals 4 tangent of 3 pi x. Okay, so our amplitude here, absolute value of 4 is 4. Let's determine our period now. Period, again, for tangent is pi over b, so pi over b here, which is 3 pi. So pi over 3 pi. The pi's cancel, and I'm left with 1 over 3. So my period length is 1/3. Okay, so remember with tangent, they have that offset quality. So I'm going to take 1/3 and divide it in half again. Okay. Well, that's the same as multiplying by a half, so a sixth. And I'm going to make one positive, remember, and one negative. So 1/6, negative 1/6. And remember, at those locations, we're going to have our asymptotes here, so I'm going to go ahead and dot those in. And if I want to then find the next location, I can take that 1/6 and divide it in half again, or multiply by a half, which is 1/12. Because 0 plus a 12th here, and that would be negative a 12th there. And of course 0 at my y-axis and x. And if I needed to add another period on here, well, how much would I add to my 1/6? Well, how much is my period length? 1/3. So a sixth plus a third. That's 2/6 plus 1/6 is 3/6 or a half. Okay, and this would be a half. And then we can go through the process of adding a 12th to 1/6 here to find my intermediates. So let me clear some of this out. So what did I do? I took my original period, divided in half, made one positive and one negative. Those are my asymptotes, a sixth and negative a sixth. Divided it in half again, and that gave me a 12th, and I knew it was positive a 12th and negative 12th. Remember, this tangent graph has that offset quality around the y-axis, which is kind of unique. Okay, so the amount that I'm adding each time here to 0 would be 1/12, right? So 1/2, 1/6 plus 1/12, sorry. If I'm going to say find my next location and next and next and so on, okay? So 1/6 plus a 12th, that's 2/12 plus a 12th is 3/12, which is a fourth, okay? And then 3/12 plus a 12th is 4/12, and that's a third. And then plus our next one would be 5/12, and plus one more 12th would be 6/12 or a half. Okay, so I can always find all those locations if I need to and do a second period. Okay, but let's go ahead and finish our first here. Now remember, at whatever these intermediate locations are here, 1/12 and negative 1/12, it's going to be up at my amplitude, okay? And we can verify this. It's going to go through 0, 0, and then it'll go here through. And so there's my tangent graph going up. And remember, it's going to be bounded by that asymptote, so remember, don't have it cross it. And it would be doing the same kind of behavior there. And it's got a vertical stretch of 4 and a horizontal shrink of 1 over 3 pi is the horizontal shrink. And then here's my vertical stretch. Okay. And we could keep on going like that and add more periods to it, doing the same method as we went. Okay. Okay, so remember with these tangent, and if we needed to evaluate, say we weren't sure, and we just wanted to confirm, well, let's try that 1/12 there. Let's plug in here. Tangent of 1/12, 4 times the tangent of 3 pi times x, but x is 1/12. Well, that'd be 4 times the tangent of 3 pi 12ths, which is pi fourths. Tangent of pi fourths, remember, maybe I'll use my original 1 root 2. This is pi fourths is a 45, so 1 over 1 would be 1. Or if I use my unit circle, 1 root 2 over 2, root 2 over 2. Root 2 over root 2 is still 1, okay? So tangent of pi fourths is 1, and then it's multiplied by that 4 out front here, so that would equal to 4, okay? So notice at 1/12 I'm up here at 4 at this location. So I can always check and confirm that I've drawn it correctly by plugging in a value and confirming that I have that. And remember, I can always use my original triangles or the unit circle, and the ratios come out to be the same, say for a 45, which again, a 45 is pi fourths, right? Okay, so let's do the next one. Okay, let's look at a couple trig identity problems, and then we'll do some sum and difference, and hopefully this will help you get going in the review. Okay, so again, I want to look for ways I can simplify this. And if I see, say, a plus b times a minus b, well, I know that's a squared minus b squared. Well, that'd be secant squared x minus 1 squared, which is 1, over tangent of x. And then if I refer back again to my trig identities table, on page 514, I'll say, oh, secant squared x minus 1, say, is tangent squared x, if I say take that 1 to the other side, right? So that's the same as tangent squared x over tan x. And then if I've got tangent squared over tangent, one of those tangents canceled, and I'm left with just tangent of x upstairs, tangent of x, okay? Okay, so again, refer to the table on 514. It may not always be in the exact form that you need, like for example with the 1 plus tangent squared on this one equals secant squared x. Well, I subtracted the 1 over, and so I had tan squared x equals secant squared x minus 1. So when I saw secant squared x minus 1, I said, oh, that's tangent squared x. So this was the original identity. And I may need to then, say, solve it for one or the other if I need it in the other direction, right? Okay, so there will be some algebraic manipulation going on to get it to where you want it to be sometimes, okay? Okay, let's do another one. 36. 36 says cosine of x, secant of x, over 1 plus tangent squared equals cosine squared. And remember, if these say verify, whereas the last one we just simplified, verify, we want to make it look like this other side in as few steps as possible. Well, let's do that. Well, I know cosine of x, and I know secant's the same as 1 over cosine of x. Over, and I know 1 plus tangent squared x is secant squared x. And I know I want secant because I'm trying to get it into the form of cosine here. Well, cosine over cosine cancels here up top, and I'm left with 1 over secant squared. Well, 1 over secant squared is the same as cosine squared, right? Because cosine of x equals 1 over secant of x, and it applies with squared as well, okay? So cosine squared equals cosine squared. I've made it look like my other side here, and I've verified, Okay, showing your steps as you go. Okay, make sure you show the process you go through. Okay, thank you.